The views and opinions expressed on this show belong solely to the hosts and their guests and do not reflect the views of any on-site institutions unless explicitly stated.
What's up, everybody? My name is Steve Vanderwall.
And I'm Justin Klosser.
And we're your hosts of Cannabis Cum Laude, a podcast devoted entirely to cannabis. We're going to talk cultivation, business, medicine, science, politics, advocacy, culture, and everything in between. Because let's face it, the cannabis industry is complicated, it's robust, and it has a ton of moving parts. So it's going to be our job to help you understand it a little bit better. So tune in every Friday morning for a brand new episode. And if you have a question that you'd like to have us answered on one of our shows, email us at questions@cannabiscumlaude.com.
What's going on, everybody? Welcome to another episode of Cannabis Cum Laude. Steve and Justin here. And today's guest is a good buddy of mine. His name is Kyle Moffitt, and he is the co-founder and CEO of STEM Cultivation. After becoming a medical marijuana patient in 2016, Kyle quickly experienced the pain of high prices, short supplies, and inconsistent quality shared by many patients across the market, and realized that the cannabis industry suffered from a broken supply chain. He and his co-founder started STEM Cultivation in 2017 to develop a manufacturing solution that would consistently lower the cost to grow high-quality cannabis at a commercial scale, yet affordable enough to be accessible by growers of all sizes to compete in the global cannabis market. Kyle graduated from MIT with a degree in architecture. Kyle, welcome to the show.
Thanks for having me, Steve and Justin. Great to be here.
Thanks for coming, Kyle.
So kind of give us a high-level overview of, what exactly is STEM Cultivation? What was your purpose behind starting the company?
Yeah, well, your intro captured it at a high level, but so STEM, science, technology, engineering, math. We're just nerds that really like cannabis, and so the purpose of the company really, as you mentioned, was. This is if you take the emotion away of cannabis, sometimes it's really hard to do that. And you just look at it from, as another kind of consumer packaged good supply chain, you kind of see, that there are some improvements, that can be made, a lot of improvements that can be made, both in reliability, efficiency, and all that. So we started the company with an eye towards the first link of that supply chain, which is cultivation. And in particular, what we wanted to try to explore was, where are the costs right now in cultivation, and for each one of those costs, what can we do to make it more efficient and bring those costs down without sacrificing any of the things that consumers value, right? And so. We started off as just kind of a logical progression of thinking. I'm not a grower, don't profess to be. I do know some things about design and space and how to use space. And so I basically just started breaking the problem down in terms of how can you be more efficient both in your space savings, your energy savings, water, labor. Like those are the big components that drive up the cost of production. And then, how do you create environments that any scale that reduce the risks of crop loss or any sort of inconsistency that is going to affect the consumer downstream. And so we started the company in 2017. We had done some experiments before that and saw that, for instance, with the method that we're using, it's, you get almost 5-6 times more productivity in the same amount of real estate using our method versus a traditional horizontal grow. And we're like, wow, this could be useful. So we developed a product and have been running a full scale production operation with some growers out in Reno, Nevada. For the last almost 2 years now, we've been out there and have had a lot of consistent results that are very encouraging. And so we are open for business, and we are actively marketing what we call the Eco-Precision Cannabis GrowRoom, or EPIC GrowRoom. We feel like this is something that can really, I hate to say disruptive or anything like that. We're equipment manufacturers, and we're trying to build equipment that, when given to the right person, they can take their skills and really elevate them, and create something that is beneficial across the supply chain.
Awesome. So sustainability is a huge problem in the commercial cannabis cultivation. We had an article recently came out that we had the pleasure of interviewing the author of, Haley Summers. It was published in Nature about the greenhouse gas emissions that are imminent when we do eventually federally legalize. Your Epic Grow Room is a nice solution to help kind of start solving this problem. Can you give us more of a overview of the Grow Room itself?
Absolutely. So the grow room is, just dimension wise, it's about 30 feet long by 10 feet wide by 10 feet high, roughly speaking. It's designed again to, whatever energy you're putting into the system, you should be able to track both the cost, obviously, but then the output of that energy. So, for instance, just take energy efficiency for a second. So we use LED, not because we have a bias towards LED. It's simply because it's the best technology for our application, because we like to have the lights very close to the canopy, and which allows us to dim the lights, actually. So, one thing that we notice, and maybe sometimes it's nice when you don't know about growing or things like that, because you don't have a bias.
Mm-hmm.
You're just asked dumb questions, and why can't you do this, or why can't you do that, and then you try and just do it. And sometimes you find solutions. So one of them is this idea of using of really dimming lights. We talk about the inverse square law of physics, right? Physics says that light intensity is a function of distance between its source and whatever the surface is. And so, when you look at how things are done traditionally in horizontal grows, these lights are shining down, and they're very energy intensive, because you have to have a certain level of intensity when you finally get to the canopy, and certainly if you want to try and penetrate the canopy, and that's just all just energy. And so we realize that the plants don't know anything. They all they know is what kind of light they're getting, and is it optimized for photosynthesis. So we realize that with our method, you can substantially reduce the amount of light that you have in there without really reducing any of the output or quality. And that reduces the heat load and obviously the electric load. So there's one area right off the bat that really didn't take a whole lot to see some efficiency gains. Another one then is the HVAC. And that's really, if I had to look at a single power drag, that was the most of anything, it's dehumidification. It's not the heat load, it's dehumidification. We can pack almost 480 plants. Well, we can pack 480 plants up to into a single grow room. And when you have that many plants in that sort of volume, you're generating a lot of humidity. And so dehumidification is actually where most of the power goes in our system. And our system does about between 750 and 1,000 kilowatt hours per day, which based on the amount of that we can produce in a box, actually gives us a very advantageous grams per watt calculation, as well as grams per square foot. So we're talking about energy, and then we're talking about space efficiency, because we can do all this biomass in a small space. But then you talk about water efficiency, right? So we're a recirculating hydroponic solution. And what that means is that we're not draining to waste. We're actually, once you dial in whatever it is that you're feeding for that week, it should just be recirculating over and over until you want to start a new feeding regimen. So and on top of that, we also recapture all the transpiration from the plant. So, it's never 100% reclamation, but we're pretty high. We're capturing all the water except for what the plant is literally retaining. So that helps reduce our water footprint. So, ecologically, what we're trying to do is say, look, nature allows you to optimize it. And plants can't take all the light in nature that they're getting. So what makes you think that they need it artificially, right? So the idea is just to take what the plant needs to grow efficiently and to maximize its genetic potential. And then make sure that you can dial that in very precisely, and again, at any scale. And that's where I think we're finding a lot of our successes.
It's really interesting because you guys have really kind of taken technologies that exist in kind of separate ways and combine them into one, right? You have hydroponic technology with living wall technology plus automation, kind of equals the epic GrowRoom. What is kind of the origin story behind, what was your idea? Hey, how do we merge these all together? What was that origin story behind, producing a model like this?
Right. So I can tell you it was not to build a recirculating hydroponic system with living walls or anything like that. I wasn't smart enough or experienced enough to even know what any of that stuff was. What I was trying to do was just think through what could you do, what is possible, and then test it to see if that actually produces a commercially acceptable result. So, the first thing we looked at was said, okay, well, if you have to choose between soil and hydro, for our application, what's the best use? And we said, well, it seems like hydroponics is the one that's most precise. It's definitely not easy. You have to know what you're doing. But if you dial it in, it's definitely more precise than soil. I'm not saying it makes better cannabis or not. Don't really care. All I care about is that can I have a precise and predictable outcome every single time? So hydroponics gives you is the best way of doing that, again, if you know what you're doing. Then the next question was, okay, well, how do we save space? And that's when we came up with the living wall concept. And all that basically is saying is that, normally you have lights up here and you have a canopy down here, right? And the canopy is growing towards the light. So all we've done is just taken that whole system and rotated the whole thing 90 degrees. So you have a wall of canopy facing a wall of light. And plants do this wonderful thing where they don't grow out. When you make them come out of a tower, they don't grow towards the light, they grow parallel to the tower. And that's just a natural phenomenon that allows us to, again, have all of that, a very uniform canopy that never really touches the light so much as just grows parallel to it, which means that we can keep that light dim the whole time. So, we use this living wall concept. And what was amazing to me on that one was that no one else was doing it. I mean, living walls are not new. You go to Disney World or whatever, you can see it, but just didn't see anyone doing it in a commercial way for cannabis. So, and then, okay, hydroponics, living wall, check. Then, how do you actually isolate all that, right? And so then we had to think of, well, should we do a shipping container or something like that? And we tried shipping containers, and we bought one and we kitted it out. And we realized, though, at some point that was not going to be a viable option. And there's this old saw in architecture is form over function. You never want to have form over function. And so when you're using shipping containers, that's you're limited by that volume of space, and it either works for you or it doesn't, right? And that didn't work for us. We needed to have a custom built space that was exactly suited for the dimensions that we were looking for. So, we had a clean sheet design and came up with something that's entirely custom, but very easy and very simple from an engineering standpoint, because reliability is paramount. You can't have downtime. You can't lose crops. So, hydroponics, living walls, isolation, right? The lighting, right? We talked about that, using LED and dimming them without affecting really any of the output. And putting that all together, the one thing that was missing was the labor. How do you actually work within an environment like this? And so, if people are out there listening, they're probably rightfully asking, well, you're talking about this wall and you're talking about it up against a light wall. Well, how do you do it? How do you manage the plants? You can't get in between the canopy and the light. Like how's that practical? And so the final kind of piece of this whole thing was inventing a system whereby you could actually pull that wall from its normal sitting space out into the aisleway so that you can manage all the plant. You can defoliate or harvest or whatever. And then when you're done, you slide that wall back into where it was, right up next to the lights. So that was how we figured out how to make it a very practical space on top of an efficient one. And so that took some doing. That took a long time to figure out. But when we finally came to the right solution, what we were able to do was do all of those things with basically, one or two moving parts, right? It just pumps, right? Because everything's gravity fed. So we wanted this to be extraordinarily reliable, and I think that it has. I mean, the one the system we have out in Reno has been basically working nonstop for a year and a half now. And there's no reason really why it should ever break down.
Wow, year and a half. No, what's the maintenance look like on something like that? Like monthly maintenance, weekly, biannual?
So, the only thing that really has that we've had to replace is the pump. There's a single water pump that that takes the water from the reservoir and pumps it up to a manifold, and that manifold rings the box and feeds each tower, and that's the recirculation. That's the whole thing. So all we need to do is get that water up to the top of the box, and gravity takes care of the rest, right? So we've had to replace one of these pumps, I think, once. The HVAC units are all commercial grade. We don't do split level units. We do, 6 tons of redundant HVAC because that's what it takes. But these are like industrial type systems. So they're meant for 24/7, 365 use. And then, of course, LED lights, they're getting pretty good nowadays. They're rated for 50, 60,000 hours of use. And the rest of it's just kind of plumbing components and things like that. There's not a lot of, and some people get upset about that. They want to see a lot more things whirring and lights blinking. But that's just extra. It doesn't help the plants.
So to add on to that, what's like, is there like a SOP as far as clean out goes at the end of a cycle? Like I got to imagine those towers got to be ripping full of roots.
Yeah, it's great. It's actually wonderful. The SOP on cleaning is very straightforward. You take the towers out. Once you've harvested, you take each tower out. They're absolutely, you're right. They're full of roots, right? And you have a hot swappable. You have another set of towers ready to go. So you run your hydrogen peroxide or your isopropyl, and you clean everything down like you normally would for any other room. Run, cleaning solution through the system. But if you have it timed right, you should have your plants already veg and there you go. So it's about 8 man hours of effort to get a box turned around from harvest to the next grow. So, if you assume a 56-day flower cycle, give or take, easily get 5 turns a year doing this. And, some people don't veg in the box very much, and they can get 6 turns in a year.
Yeah, I mean, it's a clone machine, right? Throw your clones in, and then what? 5, 6, or 8 weeks, and you're churning and burning. And the reality is, you guys, I'm really interested for you to kind of elaborate. You guys had some couple of case studies out in Reno, but one particularly stands out, which really would produce some really profound metrics. Can you talk a little bit about that one case study?
Absolutely. So it's we did some test grows before we built the full scale production system, and we'd gotten some great results, obviously, but we had no idea what it would look like at full blast, right, at full scale. And so the first time we did that, we actually put in what was like 458 plants. We didn't even do 480. We did like 458, and it was Double Dream was the cultivar, and we got 92 pounds dry from that yield, and we weren't expecting that at all. Based on our tests, we were expecting 60. The customer was expecting 30, and just as a major comparison. This particular customer actually had some shipping containers that they were using. They had before us, that as a room, and in those rooms, they were only pulling 20 from twice the amount of space, and we pull out 90. And those are all recorded with the state, Nevada. Like those aren't you get taxed on the weight that you submit to the state. So there's no incentive to overinflate anything. And it was just remarkable. I couldn't, sometimes things just work out. and we've gotten those kinds of results ever since. So we tried things with different cultivars, more sativa leaning or indica leaning or whatever. And it really doesn't matter. We're getting between 3 and 3.5 ounces dry per plant, whether you're doing 400 or 240 or whatever it is you want to do. So that also makes it very predictable in terms of your business, right? I mean, the idea is that with a box, a GrowRoom, you have a consistent capital expense, consistent OpEx, and consistent output, so you can run your business a little bit more predictably. So back to the 92 pounds, that's all wonderful, but it's so cartoonish. It's like way out of proportion to what anybody is expecting. So automatically your credibility is questioned. Because people just couldn't imagine that that's possible. But the fact is that if you put plants in the right situation physically and put them in the right kind of controlled environment, you'd be surprised what they do, But it does blow away some of these kind of standard metrics of efficiency. For instance, if you're doing 50 grams per square foot, or 55 or 60, that's pretty good typically in a normal grow. We're doing 120 grams per square foot. And that's if you count the entire footprint of the box. The actual grow room is not that entire footprint. It's only 240 square feet. So if you want to use that calculus, it's like 184 grams per square foot. Even the plants themselves, if you want to do an apples to apples comparison of grams per square foot, our Canopy is coming in at 80 grams per square foot plus, right? If you just want to look at that, almost 4 pounds of light. That used to be a metric that people cared about. I'm like, it doesn't matter. Like lights do matter. I'm not saying they don't, but again, it's the plants that are, you put them in the right situation, they're going to blow your expectations out. And so that's been obviously a wonderful thing for us, and validates the model completely. But there ain't no free lunch, and sometimes people just they just assume there's no way that we're telling the truth, and you just can't do it that way, because you can't get those kinds of numbers doing a traditional grow. I've never heard of anyone that's even tried to claim that.
Yeah, I obviously never have either. it's one of those things where I honestly think it's almost so advanced for our time. We're coming out of the prohibition area and still talking about, home grow and small, horizontal grows. And all of a sudden there's this technology that comes out that can produce, really 92 pounds in the size of somebody's living room, which is just outrageous. But from a sustainability perspective, what in terms of, how does the carbon footprint compare of this type of grow environment compared to a traditional grow?
Yeah. So, I mean, it's, again, you can imagine that the energy we're putting into this system, like I said, it's between 750 and 1,000 call it 70,000 kilowatt hours of energy per harvest, right? To create that much biomass of that quality. And so, from a grams per watt standpoint, we're doing, very well. I think like I'll have to look it up. I don't want to say something wrong, but it's very good. Like the density light, the light density calculation that, like, for instance, Massachusetts requires larger installations. You can't be more than 36 grams per watt, I think. If you're smaller, it goes up to 55 grams per watt. We're at 34. And that's with the lights at full blast. I mean, we have, at that point in time, we weren't even smart to be like, hey, we can dim these lights and be fine. But so even a full, like, we're below those thresholds. And, like, again, the water from water standpoint, it's 110 gallons to charge the system. That's pretty much, you're using that plus whatever you have to the plants take in. So, call it 120 gallons, 130 gallons a week that you're using. It's just meant for maximum efficiency.
No,
I actually want to backtrack when you mentioned, like, the plant canopy, and so that got my head spinning on this 3 to 3.5 ounces of plant. And I was watching yesterday, actually, the walkthrough with Kyle Cushman that you had. And looking the home, right, for the plant to go into, they seem relatively close together. So how big do these plants get at the finish? Like, are we talking like 3 foot high plants? Are we talking just massive buds on a 1 foot plant? Like, I'm curious.
Yeah. So it's basically a sea of green. It's a vertical sea of green type setup. So you're going to have, these plants are going to be in close quarters. And obviously you want to maximize the usable part of that plant, and so you don't the plants will grow between 2.5 to 3 feet high when it's all said and done. And what's really key, though, is when do you put plants into the system? Okay, and if you actually put them in as small as they can be, and still access the nutrient water. So that's really the determining factor. If you put them in too large, they end up becoming a little more stringy than necessary. And so there's an art to this. And again, this is part of our SOP is determining when's the ideal time to bring those plants in and flip them to flower. So if you do it at the right time, you're going to end up getting a fairly uniform wall of colas, and that actually there is no top or bottom to our canopy. So there's only just two sides. There's two canopy sides. So the light penetration, and by the way, that distance between the front of the canopy, the light, and the back of the canopy is limited by the towers in which the plants are growing out of. So my point being is that canopy can't be that thick anyway. So now you're talking about getting much more light through these plants without having to do the lollipopping and the whole 9 yard, all that stuff that people have to do because they're trying to maximize the efficiency of the plant. We don't really have to do that. It's not that people don't have to manage the plants, but just plant management in our context is a little different than in a normal grow.
I was actually thinking about that a couple minutes ago. Like, do you guys, is there a way to employ plant training techniques, like lollipopping or topping or stuff like that? Is that something you guys have tried, or is it unnecessary? Or what do you, if you haven't, what do you think the outcome would be?
Yeah, well, lollipopping is kind of necessary because, again, that lollipopping is if you have a top and a bottom to your canopy, and if you don't have that, then that's not as big of a deal. Defoliation, absolutely. You want to, there's a best practices that. But we tried super cropping. I didn't even know what that was. I got to tell you, sometimes I'm amazed how much I don't know. But super cropping and things like that, where you snap the bud early on, or early on in the grow cycle, and it really knuckles up and helps to create a bigger cola. All those things are valid in this system. There's nothing that any technique that you have figured out that increases the output is something you probably do. It probably doesn't matter whether it's a vertical orientation or a horizontal one. If it works, it works.
So with a maximum canopy efficiency and lack of lollipopping, which is by traditional standards, it's a function of the light's not getting down that far, but it's also airflow. In order to help prevent pathogens and stuff. So with such a dense canopy, do you have you seen issues with pathogens, or do you have is the air circulation going on just on point? I mean,
yeah, no,
I don't know a better way to word that. Sorry.
This is very, very important. So certainly the amount of defoliation that you do is going to help with that airflow. Also, our HVAC systems are so beefy that they are blowing out air at a pretty high velocity. So that helps with the circulation just inherently. But we still augment with little fans and things like that. No reason not to. We're not trying to prove anything. We're trying to create a system that you can augment and otherwise, so like we use fans, we have UVC filtration that goes on. These are all just things you can add, sensors, whatever you want to do. This is an agnostic platform that allows, like I said, experts to come in and do what they typically do in a horizontal grow, but perhaps do it more efficiently, or maybe make more than they ever thought they could.
So I want to talk a little bit about the economics of this, right? Because you said 92 pounds of flour. Let's go off kind of the math and the numbers that are happening in Massachusetts right now, because I'm really interested in this, because in my head, this helps small craft growers be competitive. Especially when you look at New York on the cusp of legalizing. And at this moment right now, the Senate is voting on legalization. It's going to the floor for a vote right now. We could very much have a legal program in New York in the next 24 hours. Obviously, there's a whole bunch of bullshit that has to happen with rulemaking and regulations. And man, do I hope that they don't take the same steps as Massachusetts is, because what a nightmare, right? Really, what an absolute nightmare. But I do think technology like STEM cultivation can help small growers really compete with some of these bigger cultivation facilities, and especially the MSOs. So currently, what is you said earlier that you can put, if done right, you can turn the box over 5 times a year, right?
Correct.
And your best production to date was 92 pounds. And
correct.
What is the current wholesale price of flour in Massachusetts?
Between 3,000, 3,500, I think was the last I checked. Somewhere thereabouts. It's ridiculous.
So I'm just going to do some math, which Kyle could probably do in his head. So let's just be super, super, super conservative and say $2,000 a pound.
Yep.
$2,000 a pound times 92 produces about 184 grand worth of wholesale cannabis flower per grow. Times 5, 920,000, right? That's remarkable to do in less than 500 square foot of canopy space. This makes, what I don't really know what the cost of a unit is, but how much time does it take, assuming these numbers, to recover your costs from the box?
Well, if you're in Massachusetts, it's less than a grow, right? Way less than a grow. If you're in a more competitive state, maybe 2 grows. It's less than a year. I don't care how competitive the state is or how low the price is. The payback is extraordinarily quick.
Now, this to me seems like a large company would want to come in and scoop this up. But from conversations that we've had, this has really been designed to be a competitive tool to help the smaller, more craft growers, right? The smaller market. How do you make a technology, like, do you guys have financing plans in place or programs in place that allow small growers that may not have, a huge wad or a huge bankroll like some of these big companies? How does technology like this become accessible, to the common grower?
Great question. So we have financing. We have financing partners that help get this into people's hands. Our licensing models, we have several, because you never know what the person's situation is. Some people, want us to. We have a program. One of our programs is called Free to 40, and what that is that we don't even charge a licensing fee until you've passed 40 pounds in a grow.
Oh.
And then because we figure if your average would be 50 grams per square foot of productivity in normal grow, and in our footprint of 342 square feet, that's approximately 38.5 pounds that you would expect to do normally in that real estate. So we have a licensing program that only starts charging you after you're in the bonus round, basically, and that plays to our strengths. And it also, transfers a lot of the risk back to us and making sure that the box performs as we say it does. Otherwise, we're not going to get paid on that. So that's one angle. For some people, like flat rates per month. But we have, basically what we have is models that are easily accessible to normal growers. That with a price point that that is allows them to take advantage of some of these huge margin gains with the technology, right? And really is we're trying to democratize this. We're trying to put this in the hands of the mom and pops. That's what makes this the supply chain work. It makes it resilient. It decentralizes things, and it allows for people to that want to do craft. They want to do small batch. They want to do specialty things. It gives them an economic way of doing that, where they don't have to make huge bets on infrastructure. Right? These boxes are standard. The grow rooms are standard. So it's kind of like a blade server model where you spin up capacity as you need to. You don't need to make huge bets on infrastructure and hope it works out. We're actually seeing we're starting to see a lot of pickup in Canada because Canada just recently came out with their own craft cannabis type license, and people are going crazy for it because the big MSOs in Canada have really missed the mark on supply. And they've are selling off greenhouses for pennies on the dollar and things like this. And what's going to fill the void are these smaller growers that they find us, right? Because it's funny, they must search for the terms that accurately describe the grow room, because they find us, and when they come to us, they're already on board. They just want to know how we get, what the cost is, right? There's no selling to that. They already get it.
How do we find this thing?
And I think, when people in Massachusetts or anywhere else, when the economics of these markets start to tighten, and they will, it's inevitable, who's left standing? And we don't want it to just be MSOs. We that's not going to help the consumer. And that's our biggest, the end user, the people that are buying these products, they're the ones that matter. It's what they want. And if they're able to get what they want more consistently from smaller growers, then that's the way it is.
So it can produce sustainably. It can help small growers be competitive and make a living. But I guess the golden question is, what's the quality of the end product?
So, I mean, if you believe that hydroponics can create high-end products, then, there's nothing different about this one. This is, again, if you know what you're doing, and we can dial it in, whatever. It's like the box itself is it's garbage in, garbage out. It'll do exactly what you tell it to do.
Yep.
Right. If you do all those things, what we have seen is pretty great results. We had a grow, and they did a cultivar called Crunch Berries, and they sold it in MedMen and a few other places in Vegas, and it sold out in less than a week. And at the top shelf, it was going for $55 for an eighth, which is, in Vegas, that's pretty high up there. And, I'll never forget, our grower partners had forwarded on the emails from these procurement people at MedMen and things like that. And they're like, this just sold out. Do you have any more? Like, we can't keep this on the shelf. And it was a small batch grow, so they only had what they had. But you're talking about really, like I said, maximizing the genetic expression of these cultivars is the key. That's what growers are going for, and so that's what we see. We see like from the THC, from the terp profile, all of those things. It's really something. I'd love to sit here and tell you that I had it all planned out in my head, but I didn't. It just worked.
I have a few more questions actually on like the components and the mechanics of how everything works, if that's all right.
Yeah, of course.
Yeah. So you mentioned that you have like a gravity fed system that gets pumped up to the top. Does that then just function as like a nutrient film technique style to like just to put a label on it? Is that what it is? Or are we doing like misters that are spraying the roots or? Okay.
No, absolutely. So it's kind of a poor man's NFT.
Okay.
Where we don't need to do any, it's just gravity, right? The roots are always exposed to the air, and they're just getting a constant bath of nutrient water. And so we don't have to oxygenate anything. We don't have to add any of those components.
It's continuous flow then? It's not like on a timer? Sorry.
I'm sorry, what's that?
Yeah, I apologize. I shouldn't have cut you off there. It's on like a continuous flow then. It's not like timer based to where it's given like a dry down time or anything in between. Just curious.
You can do whatever you want. You can do whatever you want.
Oh, okay.
Yeah, no, it's we've got the knobs and the levers for you.
Okay.
We're one of my business partners says we're the Viking stove, right? You're the chef, we're the stove. I'm a hick, so I say things like we're the combine, you're the farmer, whatever, right? So however it works for you. But no, exactly. And these root masses, when they come out, you see them and it's like super healthy, and it's what you'd expect in an NFT type system. We just get it for free, basically.
That's awesome. We were actually just kind of discussing that a little bit on last week's episode when we were with the Hydro guy, Rob. We were kind of going back and forth on whether NFT was really even like a feasible thing in cannabis because of the massive root systems that could be performed. So that's awesome to hear that you're actually killing it with the system that we were putting into question. But
again, I really wish I'd have thought it all through and had that, but it just worked out that way.
My actual other question was kind of piggybacks off your levers and switches there. So is there like an external module to where like I can have a digital readout of what my humidity and all this is, or like does it sync to your phone or something? Like what are the environmental givings, if you will? I don't know a better way to term that.
I know what you're getting at. So we are agnostic to these systems. We are not trying to reinvent the wheel. There are very, very good companies out there that
Okay.
have very good tech for these things. So we just plug in to things, right? I mean, we can include them if you like, but if you already have those systems in place, it's meant to just plug in. So, and we choose our vendors carefully for that, like our HVAC vendor, our lighting vendors, things like that. We make sure that they have the capacity to plug in to these systems for exactly that. But we made a conscious choice, at least at this point, to not try to get into that game. We prefer to partner up with these people and let them do their core competency, and we'll stick to ours.
Cool.
Smart. I feel like some people try to do everything. And, I think if you stick, there's a lot of people out there that are doing really good work in environmental controls and lighting and HVAC and equipment manufacturing. And why reinvent the wheel? Just put rims on it. But I guess that kind of wraps up. Do you have any more questions?
Oh yeah. I got a bunch. I didn't know if you wanted to dive in with.
No.
Okay. So I'm like a kid in a candy shop here. Sorry. This is like my playground. So as far as lighting goes, is that same type of thing any kind of manufacturer, or do you have like a specific spectrum, or I guess I don't know if I want to say brand or not, but I'll throw brand out there. Or do you pick like a couple wavelengths? Are you full spectrum, or is that same plug and play type situation? Sorry.
It's the same kind of plug and play. So we have our preference in vendors, people that we've tested that have done well for us. I'll give a shout out to BIOS.
Okay.
BIOS, they're my, and we use the LIs, but we've used Fluence in the past, and we're not, we like what we like, but what's really important is more the form factor than anything, because people are, there's innovations going on in lighting and things like that. But what's important to us is the form factor of those lights able to conform to our system, right? And so, like for instance, the BIOS LIs are perfectly suited for our system because you can separate. There's no ballast, and you can separate the light bars from the power supply. And you can mount the light bars independent of one another and things like that. And that's what you need to make a wall of light in our system, right? If you had, if you had a kind of a normal LED system with like ballasts, or they're stuck, not stuck together, but they're together. You can't separate the light bars and something like that. That wouldn't work so well with us. But as far as like lighting tech and the full spectrum and things like that. We do our research, but we're by no means, experts in this. So, we work with our customers and we work with our vendors. Same thing with HVAC, they know what our they know exactly what our use case is at this point. They know what we're doing. And so they, as best they can, try to, make sure their products can work in our environment the way we need them to.
Awesome. And then I guess my one final question, just because it's a newer area of interest for me that I've been, projecting onto everything I look at. So this box is obviously already really sustainable, right? And so, but I see a potential avenue to maybe even increase that. Do you think that there's a capability of making this like an aquaponic system, and to where you could then also have use that fish water for your hydroponics, but then also maybe even have like a fish product? You know what I mean?
I like the way you think because it's innovative, and I think it's interesting. I've thought about this a little bit and how you might be able to do it, and there might be a way, because at the bottom of the towers, right? So in the towers that make a wall of canopy, the water drains into tubs, and the tubs feed a header, and the header goes back to recirculate. So you might be able to put fish in those tubs, every single one of those tubs, and get an aquaponic set. I thought about that. I haven't had a chance to test it out, but I like the way you're thinking, and it might be possible.
Awesome.
I'm actually converting. I have a rain barrel, which apparently is illegal to have in New York, and I'm turning it into a little aquaponics system this year. I'm going to stock it with fish and see what happens. So, for my vegetable garden, not my cannabis garden, for my vegetable garden. But I think that's we're coming to the end of time. Thank you always for coming on here and being a smarty pants and sharing your your innovation. And I'm really excited for you guys, especially excited because I do think that this is ahead of its time. And I think with New York, literally probably could have even went to a vote right now. This is something that I could see helping to prop up infrastructure in New York State. I myself see myself kind of niching myself as a craft grower or getting involved in something like that. And I would love nothing more than to be able to leverage this technology. And I know a lot of other people that would too. So thank you so much for your time. Is there any, final thoughts, anything cool in the pipeline you guys are working on, anything you want to share before we sign off?
No, only that we're selling. We're actively selling these systems, and we're looking for early adopters. And we're going to work with you. If this is the right solution, the right tech for you, then we're going to work with you to make sure that you can get it in your hands. We're excited. We want to go out there and help a lot of people out, and I think we can. So, we just launched version 2 of the product. And it's completely re-engineered and architected specifically for this use case. We've taken all the lessons learned from the last year and a half or so, and we've applied it to the new model. So we're ready to rock and roll.
If people want to know where they can find more information or check your products out, where do you want to go? Go ahead and plug all those socials and everything.
That's right. Well, I appreciate you guys having me on. I love what you're doing. I told Steve the other day that I think that the way what you guys are doing and the types of discussions you're having are sorely needed. You're really filling a gap for us. Thank you so much.
I appreciate it very much. I hope we can have another conversation, and hopefully in the next year or two, we'll start seeing some STEM box pop up in New York State.
Absolutely.
Hopefully.
Well, everybody, this has been another episode of Cannabis Cum Laude. Again, our guest today was Kyle Moffitt, CEO and co-founder of STEM Cultivation. And Kyle, before we sign off, I think Justin just asked you, I think we lost you for a bit. Where can people find you to contact you or to learn more information about the product?
Yeah, so you can go to stemcultivation.com or howtogrowfast.com. We have a lot of banners out there that if you happen to see a howtogrowfast.com, that's also us. So either one of those, and it will give you the information on how to contact us and some summaries of what I've been talking about today.
Right on. And we'll make sure to include those links in the show notes so people can access them. Thank you very much. Everybody, we'll see you next week. Thanks to our friends here at Rockbox Recording and Production in Rochester, New York. They are a full professional podcast and video studio designed by a radio guy for podcasters. Audio, video, voiceovers, editing, whatever. Mouth off at Rockbox at rockbox.com.
You can follow Cannabis Cum Laude on LinkedIn, Facebook, Instagram, Twitter, and Cannabuzz. Type Cannabis Cum Laude into your search bar and you should be able to find us, but the links will also be posted in the episode notes as well. If you want to help support the show, head on over to Patreon, and that will ensure that we're able to keep the best quality sound and video coming to you on a regular basis. And if you liked what you heard today, please don't forget to rate and review the show.